All right, so talking about systems of equations, we're going to have three methods to solve systems of equations. The first method is solving by graphing, and graphing gives you a really good visual of how to solve a system, but it does have some shortcomings, especially when we're doing this paper and pencil. If your answer is going to come out to be not a whole number, it becomes pretty difficult. But our main idea here, systems of equations, a set of two or more linear equations containing two or more variables, and has solutions in any xy pair that makes both equations true. So you can either have one solution, no solutions, or infinitely many solutions. But for the most part, we're going to have one solution. Two lines can only intersect in one place. So when we're working on trying to see is 4, 1 a solution to this system? Again, 4 is your x, 1 is your y, so we put 4 in for x, 1 in for y. So we get 4 plus 2 equals 6. 4 plus 2 is 6. You get 6 equals 6. So that's good. In the second equation, again, putting 4 in for x, 1 in for y. 4 minus 1 is 3. We get 3 equals 3, so that's good too. So 4, 1 is a solution. All right, and that's all we're doing for these. So we go to letter B here. And this is an important skill, substituting and evaluating here, just so that when we get to solving, using a lot more algebra, like solving by substitution, solving by elimination, you can always go back and check your answer here. So -2 plus 10 is 8. We get 8 equals 8, so that's good. My second equation, 3 times -1 minus 2 times 2. All right, so we get -3 minus 4 is -7. So I end up with -7 equals 5, which is no good. Okay, so this point, -2 or -1, 2, has to work in both. So it worked in the first, so that's great, but it didn't work in the second, so no good. It's got to work in both. Oops, let me move that down. All right, so definitely not a solution. All right, so let's go down to C then. So we get 2 plus 3 equals 5, and then 5 equals 5, so that's good. In my second equation, I'm going to have -2 times 1 plus 3 equals 1, so it's going to be -2 plus 3 equals 1, so 1 equals 1. Moving down then, we got 2 more here. So put 2 in for x, minus 2 times -1 equals 4. So that's going to be 2 plus 2. -2 times -1 is positive 2 equals 4. So 4 equals 4, so that's good. My second equation, I have 3 times 2 plus -1 equals 6. So that's 6 minus 1 equals 6. This is not going to work out because I get 5 equals 6, which is no good. All right, and then final one here. We got put -3 in for x, -4 in for y, equals 7. So 3 times -3 is -9. -4 times -4 is positive 16. So -9 plus 16 is 7. So we get 7 equals 7. In my second one, put -3 in for x again, plus 2 times -4 equals -5. So that means we end up with 3 minus 8 equals -5. 3 minus 8 is -5. So negative 5 equals negative 5. So negative 3, negative 4 is a solution. It worked in both equations, so we're good to go there. All right, so solve by graphing here. You're just going to graph these two lines and see where they intersect. So first up with y equals 2x minus 4. Start at 0, negative 4, my y-intercept. So 1, 2. And my slope is 2 over 1, so up to right 1. Next up, we have this negative 1/2 x minus 9. So start at 0, negative 9. Slope of negative 1/2. So down 1, right 2. So down 1, right 2. That's about as far as we can go there. I can also go up 1, left 2, but just so you know what direction we're going here. And I can see where we're intersect at. And that's at 1, 2, 1, 2, 3, 4, 5, 6. So that's my solution. Negative 2, negative 8 is my solution to this system. All right, it's going to work in both equations. Again, if I put negative 8 in for y in the first one, then 2 times negative 2 minus 4, so negative 8 equals negative 4 minus 4. So negative 8 equals negative 8. That's good. Second equation, negative 8 equals negative 1/2 times negative 2 minus 9. So it's going to be negative 8 equals 1 minus 9, so negative 8 equals negative 8. And you're good. Okay, you don't have to check your answers down here, but it's certainly highly encouraged. It's easy to make mistakes when you're graphing, especially like I said, when we get to two methods we have using a lot of algebra, trying to solve these. It's not a bad idea just to throw these in real quick, make sure everything checks out. If you accidentally gave one of the lines like a negative slope or a positive slope, whatever, it's always good just to throw those numbers back in, make sure everything works out there for you. All right, so moving on to this next one, I have y equals negative 3x minus 5, and y equals 2x minus 10. So y-intercept at 0, negative 5. So I got my y-intercept there at 0, negative 5. And my slope is negative 3. So that's down 3, right 1. I probably should have kept my pattern going here. 1, 2, 3. We're good. 1, 2, 3. All right, just see what those whole numbers are. All right, so then with y equals 2x minus 10, we're starting at 0, negative 10. Slope is 2, so up to right 1. Up to right 1. There we go. They're going to intersect each other right there at 1, negative 8 is going to be our solution. All right, so we substitute, again, So that's my solution, 1, -8. That's where they intersect at. That's my solution. If you want to check it out in both these, you can. I put -8 in for y, 1 in for x, so I get -8 equals -3 minus 5. So -8 equals -8. And we're good. All right, so works in both. We get -8 equals -8, and -8 equals -8. So we're good to go. All right, so when you go to graph and it's not in slope-intercept form, you want to go ahead and get these in slope-intercept form. It just makes life a whole lot easier. You could graph from standard form here, but then you're only getting 2 points on the line. I like to have the slope so that I can make all the points across the whole graph here. You don't want to try and freehand anything here. You're going to get yourself in trouble. So again, I got to get this into slope-intercept form. Divide everything by -2 here. So my equation here is going to be y equals 3x plus 6. My second equation, I have 6x plus 4y equals -30. Let me put that 0x there. I gotta subtract 6x from both sides. So I have 4y equals -6x minus 30. Divide everything by 4. Y equals -3 halves x minus 7.5. Okay, so 3x plus 6, y-intercept at 6, slope of 3. So you can go up 3, right 1. I can also go down 3, left 1, which is what we're going to have to do. I know it's tedious putting all those points, but it is beneficial. Like I said, you don't want to just go ahead and plot 2 points and then try and draw the best straight line that you can. You want to put all the dots there so you know where it's going through at whole numbers. Most of the times on these graphing problems, unless I'm going to let you use Desmos, I'm going to make them whole numbers because there's too much guessing if we're freehanding this. If I let you use Desmos, that'll give you an exact answer. Obviously the computer's a lot better at graphing than all of us. The graphs are a lot more exact. So this second one, my y-intercept's at -7.5. So we're right in there. So if you think about this, if I put 1 into here, I'm going to have -1.5. -3 halves is -1.5. So -1.5 minus 7.5. So it's going to be -9 there. So 1, -9. If you want to go to the right at -1, you're going to be adding 1.5 to that. So that'll be -6. And then once we get to a whole number here, my pattern is up 3, left 2. You see where we intersect right there? All right, so they intersect at -3, -3. Okay, so check your answer then. I would put it back in the originals. So it'd be -18 plus 6 equals -12. -18 plus 6 is -12, so -12 equals -12. Over here, 6 times negative 3 plus 4 times negative 3 equals negative 30. So it'd be negative 18 minus 12 equals negative 30. Negative 30 equals negative 30. All right, so let's go down to letter D then. So it's just the first one that we got to get into slope-intercept form. So that means I'm going to have 2x equals negative, or sorry, I'm going to have 4y equals negative 2x plus 12, and then divide everything by 4. So my equation is going to be y equals negative 1/2 x plus 3. All right, and then our y equals 1/3 x minus 3, so y-intercept at negative 3 there, slope of 1/3, so it's up 3, up 1, right 3, up 1, right 3, up 1, right 3. Okay, so I picked this example out here to show you that our method of graphing is going to be a decimal, okay? So there, there is one solution, okay? It's just a fraction. It wouldn't be a bad idea to use Desmos in a case like this. So if you have the Desmos graphing calculator either on your phone, or on the computer, it doesn't really matter. I'm going to show you real quick. So we got 1/3 x minus 3. So our answer here is going to be 7.2 comma negative 0.6. All right, so that's it.